All right. So we'll continue with our notes here. Exercise 23 and to 26. That's kind of the homework questions, right? But don't need to write those down. Just write down, find the distance between the points. That's what you want to do. And graph it first. All yours. All yours to graph first. See what comes up and give me an answer when you got it. I walk around, you guys do it. Some people have graphed it already. If you have a graph, you might as well graph it and see what happens. And if you got a number called 7, I think you're doing great. Let me just walk around real quick here. Almost there, yeah. And the distance, it's a horizontal line, is that right? And with the horizontal line, we can get distances really, really easily. Because what we do is we just put a little dot where it needs to be, which is right there. Yeah, so it's 7, easy. And we can just count the number of spaces from that one to the next one. The next one, this is too easy. I understand. So what happens is that if we do this here, what happens if we don't make it a horizontal line, or vertical lines are going to do the same, right? Yeah. You can just count and you're done, right? So, and if you're taking, you guys talked to me, Cornell notes, was that useful or no? Let's take a vote here. How many, raise your hand. Cornell notes the way like doing stuff on the side. That's called the distance of a horizontal line. That's kind of what we're studying right here. Or I don't do Cornell notes. Okay, cool. So let's do both here. Raise your hand if you did it by Cornell notes, kind of do it off to the side, make a summary. Good, that's 0. Okay. Okay. Raise your hand if you're not doing it by Cornell notes. That should be everybody. Okay, that's good. You're one or the other, right? It's either N or not N, right? Can't do the middle one. Okay, jamming. Okay, so what happens if it's not horizontal and if it's not vertical? Talk to me.
You need the distance formula.
Oh, yes, we need the distance formula. That's cool. No?
You can also subtract the, you can subtract both of the distant or the certain coordinates from each other and find the sum of both of those final coordinates that are
Sweet. Okay, awesome. So let's go with it a little bit here. So not write this one down, maybe. Let's see. This is what I want you guys to do is get the distance. Actually, yeah, let's see. I want this here. Yeah, we can do it this way. Yeah, let's do it. Let's, if you can keep on writing this down here. That's what I want. I want to know the distance. I want to know the distance of that line right there. We'll do this one together. Wow. No problem. Can we, you guys talk to me here, can we put somehow a horizontal line into this mix?
We could connect the dots and have that clear out.
Oh, awesome. Okay, so we'll do that first, and then we'll see if we can get it from a. So yes, we can get this little dot all the time. So whenever it's not a horizontal line, I think I can kind of move this across here, move that across there, and get this little dot right in the middle that makes a horizontal line and the vertical line. Are we good there? It's kind of like right there. I stop there, and I go there. And then sweet, no?
So then then you find the distance of each one. So it is 4 over and 3 up.
Sweet, okay, hold on, let's go with it. It's always gonna be a right angle right there, right? Because I went horizontally and then I went vertically.
Right.
Voila, and I'm gonna back up, so here. Tell me the distance there.
4.
4. Tell me the distance up here. 3. And then 5, yes, because you guys already know the 3, 4, 5 triangle. Or we know Pythagorean theorem. Let's see. do a few things here. I'm going to do Pythagorean theorem says that if you have a right triangle, right? A squared plus B squared is equal to C squared. We can do a whole bunch of stuff there. But just to remind you guys of the Pythagorean theorem. And you guys know the 3, 4, 5 triangle. It's been ingrained into you quite a bit. So let's do this here. Let's see. Really good question now. Let's go, Jan. So I have a 3, 4, 5 triangle. I have anybody know other, we were called Pythagorean triplets. That's what they're called. Any other one that you guys know of? No. Yeah, I don't think that's gonna. Good guess though. I would rather have the guess than not. Oh, that gets me. Not 9, right? No, that does not work. That's not true. Okay. There is another one. I think it's like this. Can you guys verify this is true? 5, 12, 13. So is 5 squared plus 12 squared equal to 13 squared? Just check. Find a sheet of paper. See if that works out. It does. Awesome. Okay, so there's another one here. Let's do this here. Off to the side, if I do stuff on the whiteboard, that means I'm going off script. Okay? We're just going to go to a different field, okay? If we're doing stuff on the board, that means it's part of the lecture series, okay? So figure that distinction. Real quick here, there's a whole field of mathematics trying to generate these numbers here. They're called Pythagorean triplets. So which ones make integer values come across? Okay, and they go on and on and on. And the question is there a limited number of answers here, or does it go to infinity? Is there, right? Can I make these forever? Can I just go higher and higher and higher? And what makes it? And then from each of these triplets, if you want, you just double it. So 6, 8, 10. Can you guys check? Does 6, 8, 10 work? All I did is I just doubled this right here. Well, no, it says it should work.
It should.
It works.
It works, okay. I'm gonna play. Okay, one more. Triple. Does that work?
Yes.
Sure. Or are you just saying yes just to say it?
No, I'm sure.
Okay. Awesome. So notice that 3, 4, 5 is kind of like the basic triangle, right? And these are just multiples of them all the way down, right? So if you want to explore this and you're bored between now and Friday, you know, it's Mr. G, is there an infinite amount of Pythagorean triplets, or there's a finite amount? Does it stop somewhere? I'm not sure. So keep on going, but it's based upon double right there. You usually call it r squared, because the radius of the circle. Okay, that's one thing. We're good. Another thing in mathematics, which is kind of fun, trying to figure it out, is this right here. That's the formula. The question is, does this formula work too? I'll just get it back to what works here. Oh, crazy. That's for cubes. Is there a formula? Is there like stuff here? What does that even mean, right? Because this is two-dimensional space off the triangle, right? This is three-dimensional space. And then the question is, does this work? And what numbers work for that? Oh man, and then you just go on and on. There's a guy named Fermat. It's down here. Oh, this guy right here. See this guy right here? Pierre de Fermat. Cool guy. He said, you know what, forget this. This is too easy. That's too easy. The question is there a generalized formula for that one right there? And he says, yeah, oh, this is so cool with math history. He says, yeah, I solved it. That's easy. And he just writes in his math book, like, yeah, I solved it. And then we find out 400 years later that there's no way he could have solved it. Because the mathematics was not even built yet to solve that. So there's a person named Andrew Wiles. Math professor. He takes the time, he takes a year off of school, takes a sabbatical, and he says, you know what, I'm gonna solve this problem. And it takes a year to solve it, and there's a YouTube channel about him, the struggle that he got, how to go through to solve that
Not
problem.
one, it doesn't work the same though.
Yes, cool, yeah, these guys don't work the same. Once you go to this one, it's totally fundamental difference when you see it. Anyways, script, we good? Boom. And if you want to look up Andrew Wiles and his interesting stuff, that's cool too. Okay. Pythagorean theorem, everybody good there? And we solve it and we get a 5 if you want to solve it directly. My computer stuck. All right, computer stuck. There it is, okay. Plug into formula, or if you already know it, that's fine. But if you're gonna do it like this here, it's gonna go like that. It's gonna go 16 plus 9 equals c squared, 25 equals c squared, c equals 5, which I think we're all good. Okay, are we jamming? Is that good? Cool stuff. And we went off script for a while. That's, I love going off script. Okay, we credit this little formula to this guy in his old age and his other old age. Yeah, I'm gonna just stop there because the Babylonian most likely knew the right one. He just was a person that learned it and then espousing Latin's figures. And we make our mathematics from the Greeks most likely, or most of the time, so we give him the credit. Okay, are we jamming? Next is this right here. This is what I need. I need a distance formula. That's what I want. And we're gonna, let's create it. So let's go back up here. And we're gonna do the same thing. We're gonna set this up. Except instead of putting numbers here, I'm gonna put this guy as x sub 1 or x1, y1. And this one is x2, y2. And we're gonna come up with the distance formula. No,
It's the square root of x1 minus x2 squared plus this, including the square root y1 minus y2 squared.
awesome. Okay, can we derive it though? That's the question. Or can we make it? So here's what we're gonna do. Yeah, that's cool though. Noah, awesome for remembering. That's awesome. The other Noah.
It's x2 minus x1, x2 minus x1 squared, like that whole squared, and then y2 minus y1 squared and equals the distance.
Cool, okay. That's awesome, guys, real quick here. That's cool that you know it, right? Now the question is, can we derive it? Can we make it from the Pythagorean theorem? So we know the Pythagorean theorem, a squared plus b squared equals c squared, right? So now can we
I'm sorry,
derive?
I misunderstood.
Yeah, no problem, no problem. So, we're here, right? Let's put a little dot right here. We're gonna be original mathematicians here. Oh, come on, back to record mode. Okay, we're here. Right there. So let's think as a mathematician here. In fact, let's put this guy together right there. That's the extra little point that we get. Name that point. Should I pick on people or no? Yeah, no. No, we're gonna label this point because we actually know the coordinates of this.
Oh, okay.
6, 1,
Say again.
6, 1.
6, 1. These little dashes that I made, they are not like numerical values because I made it all abstract right here, right? So these are just abstract points. I just did the notches.
x1, y2.
Why x1, y2?
Because Y1, X2. Yeah, sorry.
X,
Uh,
go ahead, guys.
X2.
Yeah.
oh,
Let's go this way.
Yeah, it is X2, Y1.
Yeah, isn't this on the same level as the other one?
Yeah.
Don't those two share the same X value? Yeah, so this is X2. And what's the Y value share? Y1, because it's this one right over here. Are we good? So what you have in your hands, and this is what mathematics is all about, is like you start off, you know this, and because you know this, you can get to this. Because you know this, you can get to this, and you start off learning everything. So here it is. Here's what you guys got. You're going to work in pairs just for a little bit here. Here's all you know. The other thing you know is from Pythagoras. Pythagoras was very kind to us, and he gave us the Pythagorean theorem. And you know that, I'm going to change it around though, real quick here. So it just kind of looks better notation wise. You know that c squared is equal to a squared plus b squared if you have a triangle that looks like this, okay? You guys, a little bit of time, work with the person next to you, okay? Can you derive the distance formula? Only thing we're going to change is this right here. Instead of calling this c, the hypotenuse, I'm going to change this to d for distance. We good? So let's, first of all, let's make that change. This is d squared now to that. We good? One change. So here's what I need to do. Here's what I need you guys to do. I need you guys to get rid of the a and the b and make it just terms of x's and y's. That's it. We're good? So this formula here, I need you to get rid of my a and b. A and b needs to go away. And I need you to just have it in terms of x's and y's, just only those. So real quick in your sheet of paper, go for it. Somehow change it to x's and y's. And if you have no clue, that's fine too, because that's okay. So let me walk around just real quick, just sort of see how you guys are processing. Processing that. Okay, real quick. D can stay because D is going to stand for distance, right? Somehow I need to get rid of A. So A is just in terms of x's and y's. And I don't know what x's and y's. You got to determine that. And then B, get rid of B. B should not be there. It should in terms of x's and y's. I can give you a hint. How about that? People that are just like, Mr. Antonio, you are gone. The hint is this. Think of this guy as your A. Think of this guy as your B. That's the only hint I'm going to give you.
Oh, that was not very helpful.
Okay.
So.
And think about how long that line is. How long is A? How long is B?
Yeah, it's true. I would be like, let's do this.
Yeah, how would you subtract? How would you subtract to give you the distance there? Okay, distance, we like distance to be positive, right? So we're gonna have to figure out a positive answer. Okay, so I mean, just walking around, guys. Just want to see if that will kind of just jump something.
That is
Up here, like, I have no clue.
because this distance, and we're finding this is look at that mess. And then we do the same thing for B. So B, x2, y2 minus x plus y1.
So this is the, they're on the bottom.
Oh, you're right, x2, y2 minus x2, y1. Such a mouthful.
Yeah, I just want to know if we,
Well, we know it's kind of
I
only.
just want to talk about the house then.
Yeah.
That's also, maybe after we get out from campus.
Yeah. Yeah.
What is Yes, awesome.
Well,
Check this out.
I don't think we can because these are right next to each other. So only simplify X to Y minus X to Y. You can't take away one of them. But you? No. No. And then I think that if you did take away, because you're not saying that this would be one, if you did take away the five, then it would turn into X. That does make sense. Plus Y2 minus Y. So I'm not saying this is correct, but this is what it will be.
Just thought of it. That's so.
Yeah, so.
Yeah, so that where X1 and X2 is.
Oh, right. So we can take away all the squares.
That's awesome.
Oh my God, how did you do that? I'm just doing myself. I could actually see my buttons down when you're calm next to each other. But I guess it is the same. Imagine if this was 2 minus like 4. Cross out both screens. We did it. I'm never gonna do this problem.
Yeah, my husband's one of theirs.
A squared plus B squared equals, so that was always plus the. But I don't think we should simplify all the way up to everybody else.
Boom. Okay, class, real quick, let's come together here. And I checked, I think almost everybody got it, or your partner got it. So that's cool. But you guys have just done kind of like original mathematics, because that's what mathematicians do. They sit there and like they ponder a question. They're like, hey, oh, I see something, right? And so, yes, we should see this. The A value here is the distance will just be subtraction. So let's say this was 2. And let's say this was 6, right? The way we get a distance of A is just 6 minus 2. And so in this case, it's going to be this X value, subtract this X value. So A, if you want to go outside, is just going to be X2 minus X1. Are we good there? Does that make sense? Everybody thumbs up if you guys totally make sense. Thumbs down if you say, Mr. Mugio, I have no clue what you're talking about. Okay. One person. All right, there's always one. Okay, so now the question is, how do we get this distance here? Same thing, right? We just take the high value, subtract the low value. So B would be Y2 minus Y1. Okay, then we put in stuff, and a lot of times in mathematics, it's like if this equals this and this equals that, then hey, then that one's equal to that guy, right? It's just a substitution process. So D squared is right here. Everything's fine and dandy. The A now has changed into X squared minus X2 minus X1, still being squared. Y2 minus Y1 still being squared. Are we good? And then anybody, what do we do? One last thing we do to make it a nice formula. Go ahead, shout it out. Square root, yeah. Square root of both sides, like this. Now, normally in mathematics and algebra 1, did you guys learn that you guys have to put like a plus and minus in whenever you do the square roots? Ha ha ha. How come we're not going to do it here?
Because you just, if d squared is gonna be equal to, it's not plus or minus, it's not added together, they're the same. G squared and x squared, it'll actually double form another equal.
Slightly off, not the final exact precise answer yet, Noah, but close.
Can't remember this far back in math.
Because in our problem here, does it actually represent something physical? Like, do we have a d value that's actually a real length of a triangle? The answer is yes. We do have a specific figure we're looking at, right? And distance cannot be negative on that. Okay. If it's just abstract mathematics and you're solving an equation, yes, put plus and minus, right? Because it's not connected to anything in real space. But if it's a distance from this point to this point, or whenever you do geometry, I think when you guys did geometry, you guys never did the plus and minus, right? Because you guys were dealing with physical things. Yeah, even that deals with stuff. Sorry, getting ahead of myself. We're gonna take square root of both sides. We're good? And da-da, we just derived the distance formula and you guys did it. How awesome is that? Here it is, write it down, keep it, lock it away somewhere, or just write it down in your notes. And there is the distance formula. Let's use it.
You still need to write the square root of, couldn't you just say x squared minus x1 plus y squared minus?
Well, if it happens to negative value, it wouldn't be.
That is so cool. Yeah. So again, let's talk about this here real quick here. So I think Noah's question is this: can you go backwards on the numbers, right? So can you do x1 minus x2? You guys talk to me, yes or no?
You can do it whatever way you want because you're squaring it, and that means it's gonna be all the time.
True, yes, because that squaring is we're gonna make it into a process. Yep. Perfecto.
Now, even if you know that it's positive, it's going to be positive on both of them, then can you not square root it?
You are gonna have to square anyways, because then the addition piece is on the inside. So the addition is gonna change it. Okay, wrote down the distance formula. Yes, in geometry, I think you could just, well, in geometry, you could just measure it, right, with a ruler if you want to, right? Because that's, anybody did that in geometry? Do you remember doing that in geometry?
No.
We're
Dr. Ray would not let us. We were like, look, sir, here was a ruler, here was the triangle. And he was like, no, we do not use measurements here.
How funny. How funny,
Literally,
okay.
there would be so many problems where he's like, and how do we find the distance of this line? And we would just like pick up a ruler and be like,
You'd be like, Pythagoras theorem every single time.
That's so funny. Okay, we got one more formula in 1.1. This one is just the midpoint formula. So we're not going to derive it, just go write it down real quickly here, and then let's jam with the rest of it here. So midpoint formula is you're trying to get the average between the two things. And the average means you add them up, divide by 2. And so that's easy enough. So if you have a point called y1 or x1, y1, another point called x2, y2, all we do to get the midpoint of that line segment is we add up the x coordinates, divide by 2, add up the y coordinates, divide by 2, and we got ourselves the midpoint. Done. And you guys are sophisticated. We'll do one easy example, and then we'll do one difficult example. How about that? Because I think you guys can handle it. Okay, Jim, here it is. Here's yours here. So plot the points, make the graph here, find the distance between the points first, then find the midpoint between the points. So that 3 things to do, all yours. And once you finish it off, you can kind of compare notes with your partner or your invisible partner. Some people have invisible partners. All right, 40 points is what I got, at least here. So what I usually do, I look at the biggest number possible, or the biggest absolute number. So 8 is the biggest one, so I will go out 8. Say again? So after you graph it, give me the distance, because I got the distance formula, that's cool. Give me the midpoint, because we got the midpoint formula, that's cool. Please remind me, when are we out of here for the day? What time?
9:45 is the
9:45. Yes. I get to torture you longer than I thought. And graph already, so absolutely graph it. Now, because we know the distance formula, guys, we don't need to make our triangle anymore, right? That triangle is only made for the whole concept of deriving it, right? Once you have your 2 points, that's it. You just plug in the formula. So that's why 1 here, if you want to label them, there's your, sorry, x1, y1, x2, y2. So we got rid of the whole point of even making a triangle. No need to make triangle anymore. All right, I'll let you guys do it, go for it, finish it out. We'll do a bit at a time here. So when you finish the distance formula, when you get a number there, check with the partner. I'll check as a class, and then we'll jump to the midpoint.
Wait, are we doing a midpoint for the?
We are doing distance right now. Distance first.
Oh, yeah.
And then how many you got the distance? How many you got the distance? And then. Yay.
This can't be right.
That's really good. So the midpoint formula has a plus inside it. The distance formula, we're subtracting the 2 terms. All right, let me start putting it down here as well.
So is this meant to be a plus next to the comma?
That should be a comma. Yeah, that's a comma because you're getting the x coordinates and then you're going to y.
Oh, okay.
All right, so this is what I got. Here's the distance formula.
Trying to do it in plus one.
Distance is given to the
I do not have the calculator. So I'm just,
No problem. Okay, here's what I got as the beginning part of it. So if I label my stuff, the x2 is 2. Subtract, then I got myself an x1, but it's negative. So it's actually 2 minus the negative side. If you got a 9 on your first part, you got a good.
It's like I'm either really stupid or.
So
Yeah, so I'm gonna, are you on the midpoint?
Subtract first and then square.
Yeah, after the square is further. Like I'm not sure where. I think it's 81 and 1.4, and then I want it 81.
I used it.
Yeah, absolutely.
Okay, here's what I got. I think most of you guys got that. So 9. I'm gonna square 12.
So yeah. 225. Yeah, I mean, it's pretty 44. Yeah.
Oh, no,
I don't know why I have that. Yeah, so now we're talking.
All right, somebody know the, let's see, the square root of 225. Is this 15?
I don't know.
15.
Oh, 15.25. Yes.
Okay, cool. Whatever you have. And, yep, awesome, okay. Everybody get 15, that's what I want to make sure.
Yeah.
Okay, and let me jump to the next one here. Midpoint formula, that's easy. Just add the two terms together. Make sure you're adding the x's. Make sure you're adding the y's and then just divide by 2. The first one, not so nice because that's your fraction. So if you left it as -5/2, that's perfectly okay. If you wrote it as -2.5, that's perfectly okay. If you wrote it as -2.5, guess what that is? Perfectly okay. So one of those three are just fine. Okay, so we got the midpoint of that, right? And we got a bunch. And sometimes with midpoint, I usually like to check it because you can kind of visually see. So go back to your graph. And as you kind of look at -2.5 and 2, is that about halfway in there? Yeah, just kind of just check on your graph. Is that about halfway? No, it's a yes. I agree with no. Okay, that was the easy one. You guys ready?
Oh, no.
Oh, there's another one.
Yeah. What makes it more difficult?
Is it harder than find the square root of 225?
Is it
harder to find the square root of 225?
How do you find the square root?
No, harder than that.
Oh, yeah, I mean, harder. You put fractions inside. That's what you do. Oh, yeah.
No,
You know, that's easy to wrong word of that.
I don't like fractions. Evil.
Dude, it's better than this.
Sure. Let me get this little guy right here, just so we can. Okay, there's your next one right there. Can you find me, okay, graph it first. Distance formula, and then midpoint formula. Oh man, this is fun.
That is. One 6. Every box.
They do my square root.
I did it to.
Yes.
I think
Or I think I'm gonna make the 3rd and 6th.
Oh, cool, okay. Let me do it on board. As you guys do this problem?
Yeah, like that. It is wonder.
And then one is like. 0.6. Yeah.
We have it as 1/6 into every square.
So it's like. Yeah, then -1/6. So 1/2.
Oh, wait, no, that was wrong.
So this is what mine looks like. Maybe like
Right.
everything is 6.
No, it's right, it's right. Wait, why is it do?
This is -1 or -1. Yeah.
This is one coordinate, this is one coordinate, so the work.
Oh, wait. But this is sure you don't want to change the whole of the six.
All right, so let's go with it. Real quick here, what's the biggest number here?
1/2.
1/2. At this point, if I'm gonna graph this guy, it's going to be, like 1 is all the way over here. That's it. Now they put their graph all the way out to like 4.
I won't point.
Yeah, it's not.
I brought mine out by 1/6.
Okay, yeah, or you can always rescale stuff, right? So if you brought out all the way to 6, like, okay, then each one is 1/6, 2/6, 3/6.
Is it where we want to change everything else? Like, I just did this, everything was a 6, that's still the same coordinate.
Absolutely, yeah.
Yay,
Yeah,
that
no,
makes
yeah,
sense.
as long as you change your scale first, and then you plot points, right?
Yeah.
You can't plot points and then change your scale. Yeah, so if I were to graph these guys, -1/3, -1/3, -1/6, then -1/2, it's this little small itsy bitsy
When you square fractions, you square the top.
top and bottom.
Top and bottom.
Yeah.
Okay, 2 box.
Hey.
So it'd be like that. I'm having such a hard time.
Is there any numbers that are any
Oh,
fractions
yeah.
that you square?
I'm just gonna remind myself that
One
each
is
box is
that, 0,
I'm doing that.
that's it.
put those dashes. to it.
Also, I've heard that dividing this row is no.
It destroyed the universe.
You
Yeah,
need some help.
absolutely.
It messes.
Minus 1, so.
Equals
Plus.
Right.
And then also, is 3/3 repeated forever? or-
Hey,
or is it-
I did it somehow.
Is 3/3 repeated forever?
Add
3/3.
This is fun.
3/3.
Okay.
But it's got to be 5. 6 plus 0.3.
Forever. Minus the fractions here, every once in a while. Well, and that's funny. Fraction, you do land on an exact value.
Then what's the name? I have my distance work on. See what I can.
I this is
It doesn't matter.
So that's 29.
I hate you. What's like?
plus.
So does that mean? What?
Yeah. Oh my God.
As long as you read these forever. All right, class, let me keep on going here. So I have this for the distance formula. It's huge.
1 second. Just a little bit longer.
Okay, so
You are very speedy.
a little bit of work here, gotta concentrate. Violet, and we can get that.
Oh, yeah. And I know.
Let me give the formula for the list. Here's what I got as far as what I put down initially. We good? And you guys check to make sure you guys got it correct.
What the square root do?
Okay, I'm not
Square
gonna be
two
able
is
to
just
solve
a square
any
two.
fractions.
It's about 1.4.
Which is not-
Wait, I can't do it.
But let's see, for this one, I do want the exact answers.
Okay.
Oh, bummer. Again, this is a tough one. You guys get through this one, we're doing great.
Is this starting to be in retro?
How do I style?
One of them were.
I'm just not gonna solve this yet.
What's 6 times 1/6? I don't know
So 118, and I think we'll go to, what do you mean? Now the question is, how do you, think about how everyone feels, how do you simplify that?
Anyway, they did it to a
Super
neighbor.
just screw top and bottom. What can you do? Or-
What is this?
Ah, but I want to check. Copy, still doing great, yes, now rationalizing confidence. But I think.
Nope. This.
Oh.
No. Okay. Oh, that just sucks.
So that's one.
If you have a number, right, you can't just spread the number.
And then, so like,
you have
for
six
those, and it would be.
Yeah, that's. But if you square one side, it would be. Then you square the other. If you multiply by 3 over 3 or 5 over 5, that keeps it the same. But if you square both sides, that does change.
I'm so sorry.
I was like,
Yeah,
literally.
just square that side, and not like-
I mean, I guess we did more of a lot. So like, it was like way harder. Actually, it's like that
Almost there, guys, almost there.
The coastal setter design, we did like. And I was like, and so I did all the best. And I was
Okay, class, I'm gonna have to give you the answer as we're running out of time.
like, oh, I know when you were.
I think most people got to this, most people got to this. Common denominators, oh man, lots of work here. And then most people got to this. And hold on one sec. Everybody got to here?
Yeah.
And everybody squared both sides? Yeah.
We
I mean, I'm
didn't
putting in
get
every
to-
single,
Oh, wait,
I'm putting in every single detail. You guys might have skipped a few things, but that's okay. Okay, and then we went to here, and then we went to here, and then eventually I think almost everybody wound up right here. Okay, and then people got.
It's the square root of 2.
Okay, maybe, let's go. So first things first, I don't like fractions to be inside the square root. So what I do is I split these off, that's algebra 1. And the square root of 1 is 1, that's awesome. Da, 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 da. And then I'm getting closer. In algebra, we don't like the square root on the bottom. It's called an irrational denominator, not fun. How do we rationalize our denominator?
Multiply it by the square root of whatever number it is. So multiply by the square root, in this case, of 18.
Cool, okay, we can multiply top and bottom by square root of 18. That's one way, and it's totally legit. The other way to do it, just to make it a little bit faster, isn't 18 9 times 2? Is 9 a perfect square?
Yeah.
Okay, cool. So we can make this into, let's see, 1 over 3 root 2 initially, we good?
Yeah.
That's one thing. 18 does become like that. Now we multiply by the square root of 2. We multiply top and bottom by the same exact number, because technically we're multiplying by 1. Right? Isn't square root of 2 by square root of 2 just 1?
How did we get 3 square root?
Sure. 18 makes 92, and 9 is a perfect square
Oh,
of 3.
Yes.
So 3 gets to go on the outside.
oh, I remember.
That's cool. And multiply, and then real quick in mathematics, I know we do this real quick here, but this is super duper important mathematics. This number is 1, is that right?
Yes.
What's 1 times 4?
4.
1 times 12? 1 times negative 18? 1 times 100? Okay, so if we, in mathematics, if we can do this, if we can multiply by 1, we technically are keeping this number exactly the same. It's super cool in mathematics when that happens, because it works us out really cool. Okay, so finishing up, no.
Can't we just bypass this whole stuff by just square rooting 2.5?
Let me just finish it off. So there's our final answer. In there.
Wait,
guys. Good. No. Good.
So couldn't you just bypass all of that, square root of 2 over 36, keep the square root on the top, 2 over 6? Because it's the exact same thing, just way simpler.
Yeah, that's what I got.
Yeah.
I did that, I took square root of 236, and then I got square root of 2 over 6. Square root of 6.
Oh, okay. Yes, true. So real quick here. Let's do that. Let me put out. All right, those. Let's show this real quick here. So Noah did it the other way. How about this? What do you guys say? Good or bad? This one right here, instead of reducing it down this way, Noah, what he did is he split it off into this and this. No way. Was that faster?
Yeah, it was.
Flip. That's awesome. Done. Oh, whoa. So sometimes maybe not good to reduce, right? Okay, midpoint. We got 4 minutes. Let's go.
Oh, I forgot about that.
I actually forgot.
I'm just gonna skip on that.
All right, we got to do that one right there. Midpoint formula. And so my suggestion is you do it one at a time. Don't try to do both of them at once. Just kind of get the X coordinate first. We need common denominators here, is that right?
Yeah.
So common denominator, if you want to do that. So off to the side, maybe -1/3 plus a -1/6. Common denominator is 6. All right, -3/6, which is a -1/2. Are we good there? Oh, that's nice. Okay, so I got that piece. Let me do, so now I have a -1/2 divided by 2. That's fun. Okay. And then we want to go on. Let me just write it like this, Noah, for now, and then we're going to do it. I just want to do the simplified version. Okay, -1/3 plus a -1/2. Common denominator is 6 again. So 6, that becomes -2/3 plus a -3/6, which makes -5/6. So this is -5/6 divided by 2. Whew. And make this bar line like a lot bigger like this, because that's like the big divider line. Sure, yeah. So let's do this one now here. So then let me work with this here. So this is -1/2 divided by 2, which makes -1/2 multiplied by the reciprocal, which makes a -1/4. And this one's gonna be -5/6 divided by 2, which makes this multiplied by the reciprocal. 5/12. So we're good there. Final answer, -1/4, -5/12. Raise your hand if you got that one before I did.
No, you were far too, not before you did.
Okay. Awesome. Okay, we are, so as far as homework is concerned, ready? We went up to, so get this little sheet out right here. We're almost done with 1.1, not quite. You guys can do up to 39 at this point. Up to 39, 51. We're going to do something called transformations. And then we have some other stuff. So up to 50, oh, so up to 39. No, we're going to turn in 1.1 as a one chunk.
You're so close to doing good.
All right, besides that, have a good day.
Fail.
That's it.